Hello dear friends, welcome to this video on our YouTube channel. In this video guys, we shall be looking at this interesting integral we have on the board friends. It is the integral of 1 over sine x plus cos x everything squared guys dx. So guys, please pause the video and give it a try. Then unpause the video now to check the solution. Done? Okay guys, let's dive in. Okay friends, if I look at this integral, I see that I have the integral of 1 over sine x plus cos x everything squared dx. So friends, what integration technique do you think can work for this integral guys? What do you think? So guys, first of all, I see that use substitution method cannot directly work because if I differentiate the bottom, I won't have the top, right? Yeah, so it's some kind of tricky, and guys, integration by part is not the way to go. Partial fraction, no guys. Okay, so friends, the first step in which I want all of you guys to do is to try to simplify the bottom. Yeah, because I think we should give it a try guys and hope for the best. Let's just go on guys. So if we simplify the bottom guys, we can see that this guy can give us just the integral of, if we simplify the bottom guys, we have 1 at the top, everything over. If we want to simplify this, we are going to have sine x times sine x. We have sine squared of x plus 2 times sine x cos x. We are going to have 2 sine of x cosine of x plus cosine of x times cosine of x. Guys, this is what? Cos squared of x. We are going to have cos squared of x. Guys, this is what we have. Then we still have the dx that way. Wait, okay. Now guys, what's the next step in which we can do? We see that guys, keep in mind that our goal is to have something at the top. Okay, that is what we want to have guys. We want to have something at the top. So in order for us to do this guys, do you see that if we can factor out some cosine of x, namely guys, if we can factor out some cos squared of x, why am I factoring out cos squared of x? Is because I want to have cos squared of x at the bottom, which can go up as what? Sec squared x. Because if I factorize cos squared of x here, what I'm going to have here is what? Tangent squared of x, right? So guys, I think that's what we need to do. So if we do that guys, we are going to have the integral of, yeah, we have just 1. Everything now divides what? Everything now divides. You factor out cos squared of x, guys, we're going to have cos squared of x into, we're not going to have what guys? If we do that, we're going to have this sine squared of x again here, guys. But if you multiply sine x, sine squared x, and cos squared x, this gives us what guys? Sine squared x, cos squared x, guys, which is not what we want. So we are going to divide that by what? Cos squared of x. This is so because if you multiply this out, guys, these two can cancel and we have back the sine squared of x here. Wait, and guys, if you do this, we are going to have what guys? If we have taken away 1, that's cos squared of x. It means what? There is still something divided by what? Cos x, right? So if we do that, we are going to have sine x over cos x. And guys, don't forget the 2 here. Keep in mind that if you multiply this cos squared of x inside, one of the cos x can cancel with this, and we are going to have for 2 sine x cos x, which is what we have here. Then guys, of course, here we just have 1. Wait, and we still have the dx this way. So at this point now, guys, do you see that we have 1, we have cos squared x, which can go up as what? Sec squared of x. So if we do that, we're going to have the integral of sec squared of x over, what is sine squared x plus cos squared x, guys? It is what? Tan squared of x plus, we have for 2 tangent of x plus what? 1. We have the dx right there. Wait. So guys, okay. Now guys, I think at this point in time now it is better because we can express the bottom now in terms of what guys? In terms of the sum of 2 squares, right? In terms of what? The sum of squares. So by so doing guys, we see that this guy now can translate into just, we have the integral of, we have what? We have sec squared of x stays the same. Everything over, we can express what we have at the bottom as, we have tangent of x plus 1, everything squared dx. Great guys, what did you discover guys? You discover that if we do a u, so if we let our u to be the bottom, that is tan x plus 1, the u gives us what, guys? Gives us sec squared of x dx, right? And that's the goal of this integral, guys. That's the goal. So in this case now, we are going to carry this. So this is going to give us what? So if we do this, guys, if we let our u to what? Tan x plus 1, then du gives us what, guys? Sec squared x dx. So we are just going to be looking at the integral of just 1 over u squared du. Guys, that's the integral in which we shall be looking at. And friends, if we do this, let's just take it over to this side. If we do it this way, guys, we'll see that this is going to give us what? We are going to just have negative 1 over u plus c, right? But what is our u, guys? Our u is simply the bottom, which is what? Tangent x plus 1. So this becomes negative 1 over, we have 1 plus tan x plus c. So guys, this is a value for our integral. So guys, thank you very much for watching the video, guys. If you found the video useful, hit that subscribe button, guys. Let's go.